Hello, 8 Purple. Today I want to talk about eclipses. So this graph might look familiar to you. It's something that we looked at about 2 days ago when we were looking at the moon's elevation patterns throughout the year. We have the moon following these blue plot points where it goes up and gets very high at one point in the month, and then it drops down and gets lower. And you can see all moon phases are represented here at different times of the month. This red line, or these red series of dots, represents what the sun is doing throughout the same month. Now, one question that I could ask you guys that I may have done had we been in class in the building is, what month is this? And so you kind of have to look at the visual clues to figure out what month are we looking at here. And the best or the most striking clue is what the sun is doing. So we can see that the sun's altitude is ever so slightly raising throughout the entire month. The sun is getting higher. So that narrows it down to a very specific time of the year. It can't be fall when the sun is getting low. It can't be winter when the sun is already very low, and it's most likely not summer because the sun is usually pretty high in the summer, and we're not quite there yet. We're over here at about 50, 53 degrees, and we end it at about 63 degrees. So we go through a good amount of change here. It's not quite high, but it's also definitely not low. So we're going to call this month April. This looks like it would be about April. You could make the argument that it looks like May, possibly, but in fact it is April. So we'll come back to this graph in just a second because it's kind of important. This is the pattern that we uncovered when looking at all those graphs in sequence. We could see that the sun follows a simple pattern where it's low in the winter, it gets higher in the spring, it's very high in the summer, and then it starts getting lower again in the fall. The new moon, because it's always in the same position relative to the Earth when compared to the sun, that follows the same pattern as the sun. The first quarter would look like this, and it would be just about one adjective, I guess you could say, one adjective off. The full moon does the exact opposite of what the sun is doing, and the third quarter does the exact opposite of what the first quarter is doing. But that was yesterday's and the day before's pattern. We're not going to really get into that too much anymore. So let's talk about eclipses. Which one is a solar eclipse and which one is a lunar eclipse? Well, an eclipse is when an object is blocked by something else. So if you put your hand in front of your eyes, you're eclipsing whatever is on the other side of your hand. So the wall, someone's head, I don't know, a piece of pizza, I don't know. So here we have the moon blocking the sun. So the sun is being eclipsed. So we call that a solar eclipse. Here we have, this is kind of a strange name. This is a lunar eclipse, obviously, but the moon isn't really being blocked by anything. We can still see it. What's actually happening is that the Earth is getting in the way of the sun. It's actually blocking the sun. It's really another type of solar eclipse. It just so happens that we're on the object that's doing the blocking. And so what we see on the moon is not the Earth blocking the sun, but we see Earth's shadow falling across the moon and kind of quote unquote blocking its light from reflecting back towards us. So it's not really a true eclipse. You would just call it's kind of like another solar eclipse. We just happen to be on the eclipsing body. This is what it would look like from the side. So here's a nice geometric view of what's happening. During a new moon, it's possible for the moon to get in the way of the sun and block its light from hitting a very small section on the Earth. And then during a full moon, what happens is the Earth's shadow is cast upon the full moon, and we don't see any of the light hitting that. So this begs the question, why don't we have eclipses every single month, right? We have a new moon and a full moon every single revolution, so why don't we get eclipses during those phases? And the answer is that the moon's orbit around us is tilted with respect to our orbit around the sun. So this red line, this faint red line here, that is the plane on which we orbit the sun, and the moon is orbiting on a tilt relative to that. So here's a better view of it, I think. This one shows something nicer. As a result, this big square here, that represents the Earth's orbital plane around the sun. So that's like the plane that we move around the sun on. This diagonally slanted plane, that slice, that is the moon's orbit around us. And you can see there are only 2 points where they intersect. Those are called nodes, and I referenced them very, very briefly in the previous video lecture. As a result of this tilt, of this orbital tilt, the moon spends most of its time either above the Earth's orbital plane or below the Earth's orbital plane, and only twice does it intersect and happen at the same time. So here's another picture of that. These are called lunar nodes, and you can see that most of the time as the moon goes counterclockwise, most of the time it's spent above the ecliptic or below the ecliptic. When it's going like this, when it's rising in its orbit, that's called the ascending node, and then when it starts coming down, that's called the descending nodes. We can visualize this graphically on that same graph that we started this video lecture with, and on the same graphs that you explored 2 days ago, where we have our moon's elevation and our sun's elevation, and something important happens in these red circles where these lines intersect. Well, these are nodes, and these happen to be the ascending node, where the moon and the sun appear on the same plane, and over here we have the descending node. So it's only in these two intersection points can you have an eclipse. But it's not just enough that they intersect, you also have to have the right phase. And as you saw before, it needs to be a full moon or a new moon. So we're pretty close here. So you can see that this would be considered a new moon, and it happens on the 11th, but it looks like that nodal intersection happens like around day 10 and a half, so it's not quite enough to have an eclipse. And the same thing happens over here. We just missed an eclipse this month in March because that node intersection happens a few days before the full moon. But had they lined up, that's the two things that would be required for an eclipse to occur. The totality is a term that we use when describing eclipses. So when one body is completely covered by the other, that's known as a totality. So that happens here and here. This would be a total solar eclipse, and this would be a total lunar eclipse. Most of the time we don't get those total eclipses, especially total solar eclipses. Those are really quite rare to be in that path. Total lunar eclipses are a bit more promising. They happen more frequently, but they still can be tricky to find. And so these are called partial eclipse. There is a third type of special solar eclipse called an annular eclipse, but we're not going to get into that today. We'll do that probably tomorrow. One more thing I want to point out is if you look at a lunar eclipse, whether it be partial or total, it's not like the moon totally goes black. In fact, it stays a little bit red. And that's because of a really cool atmospheric phenomenon that happens that is basically like the sunset. So as the sun's rays go through our atmosphere and just skim right through our very thin atmosphere, all of the lower wavelength, or I'm sorry, the higher frequency wavelength light gets scattered. So the blue lights, the greens, and the violets, and the only one that has a wavelength that can penetrate our atmosphere and keep going is red. And so all these other lights scatter, and the red light hits the moon, and that's what bounces back to us. So essentially what's happening is all of the world's sunsets are being scattered away, and they're being reflected off of the moon back at us during a total lunar eclipse. Okay, so the exit today is based on this very short video lecture. I don't think you'll need to do any additional research, but you may want to have Google open as your friend. Go ahead and take that, and thank you so much for watching.